Alright, so let's talk graphing these lovely transformations and their parent functions and all that kind of good stuff. Normally, you're given a real function, not just some random set of points, but occasionally you are given these random set of points and expected to know how to transform them. Alright, so that f of x minus 3 plus 2, well, that minus 3 on the inside tells me that I'm going to be shifting all of my points right by 3, and then that up 2 is going to tell me I'm going to be shifting all of my points up by 2. So literally one at a time, I'm just going to go, okay, take this point, and I'm going to shift it right 3, so 1, 2, 3, and then up 2, 1, 2, bada bang, bada boom. Alright, shift right 3, 1, 2, 3, up 2, 1, 2, right 3. Assuming you guys are getting tired of hearing my voice. Right 3, 1, 2, 3, up 2. And play your favorite game to connect the dots in order. Hopefully you guys draw a little bit nicer than I do on a computer. Alright. And then the next one is going to be negative 2 times f of x, so it's just going to be a vertical stretch of 2, and that negative on the outside is going to actually reflect me across that x-axis. So what's happening with all of my points is I'm literally just going to be multiplying my y's by negative 2, so all of my y values get multiplied by negative 2. So right now this particular y value is at 4, so multiplying that by negative 2 should set me at negative 8. Alright, my next one is at 3, meaning my y value, so I should go down to negative 6. I also gotta recount just to make sure I don't mess this up. My y value currently here is at 0, so it's just gonna stay put because anything times 0 is still 0. And then finally, my y value here is at negative 1. So it's going to get multiplied by negative 2, which should put me at positive 2. Alright, connect your points. It's going to look weird, but make sure you connect them in order. So it goes boom, and then boom, and then boom. If you hear a cat meow in the background, I just adopted a cat, so I apologize. Next one. So the next one has f of negative x, so all that's going to do is have your reflection over your y-axis, or you can just think, hey, I'm going to take my x values and I'm going to make them the opposite of what they are currently. That's cool too. So I'm going to take my point here, I'm going to reflect it over the y-axis. So reflecting over the y-axis will put me here. Reflecting over the y-axis is still going to put me here. Reflection over the y-axis, and then reflecting over the y-axis should put me right there. Connect your dots, and you're done. Alright, moving on to my next one. I've got f of 1/2 x, so all that 1/2 is going to do is it's actually going to horizontally stretch by 2, because remember, we multiply by 1 over b, so 1 over b, which is that 1/2, which is going to change into keep, change, flip. So I've got 1 over 1 times 2 over 1. So I'm actually going to be horizontally stretching by 2, actually. So all I'm going to do is I'm going to take my x values, I'm going to multiply them by 2. So my x value right now is 2, so it's going to change into being 4. 0 times anything is still going to be 0. 1 times 2 is going to give me 2, and then finally 4 times 2 is going to give me 8. So connect your dots, and you shall be done with this problem. Moving on to the next one, we've got f of 2x minus 6. So the first thing that we have to remember before we even start transforming anything is that we have to remember that, hey, I've got a 2 out in front of this x, I need to rewrite it like I had way up here, which is having that b technically out in front of some parentheses. It makes our lives a little bit easier, and it makes things a lot easier to see. So the first thing I'm going to do is I'm going to factor that 2 out of what's on the inside of there. So I'm going to have f of 2 times whatever is going to be left, which is going to be x minus 3 on the inside of those parentheses. Alright, so what does this tell me? Well, that 2 is technically still inside of my function, so it's actually going to be a horizontal shrink of a half. Alright, and then that minus 3 is actually going to still shift my function right 3. So, Ms. Schuessler, what the heck is actually happening? Well, I'm actually going to be multiplying my x values by a half, and then I am going to be adding 3. So, looking at my x value, I have -2 and then comma 4, but I'm only going to be affecting my x values. So cut that x value in half. That would put me at 1. And then shift that right 3. 1, 2, 3 will put me at positive 2. Alright, multiplying this by half isn't going to do anything. Shifting it right 3 will. Alright. Multiply by a half will put me at a half. Shift right 3 will put me at 3.5. It's going to be skinny. And then finally cut my x values in half, so it's at 4, so half of that is 2, and then shift right 3, 1, 2, 3. And then connect your dots in order, and you should be done. Alright, last example. So I've got the absolute value of f of x. Since my f of x is in absolute values, that means that it is going to affect my y values, making all of them positive, because absolute values make everything positive. Alright, so my f of x, well, this already has a positive value for my particular y value. Cool. This particular point already has a y value that is positive. This technically has a y value which isn't affected. And then finally, what actually gets affected here is I have a negative y value of -1. So I've got to make that positive because that's what absolute values do. So flip it over to being positive. Connect your dots. And you are done with this little section of notes. I will see you in class tomorrow. Have a great rest of your day.